Hey everybody, it's Mrs. C, and I am coming to you with a new video. Getting late in our school year. No, if you're listening to this live, or, well, it can't be live, but if you're listening to this currently, it's really close to summertime, and that means it's time for most algebra teachers to address quadratics, and always with quadratics, we deal with radicals. Now, in Algebra 1, we deal mainly with the square root. So, radicals can be any root, whether it's the square root, and that's implied when you look at the symbol without the little index number. This is called the index. But there are other things, not just square roots. There are cube roots, there are fourth roots, there are fifth roots, and so on. And so we have a word, a radical, for this symbol, meaning it's just a symbol to tell us that whatever is inside, what we're seeking is the number times itself, if it's a square root, the number times itself 3 times, if it's a cube root, and etc. The number times itself 4 times would be a fourth root. But in Algebra 1, we focus on square roots, and we don't just focus on just the simple square root. How about this one? Everybody, an oldie but a goodie, right? What is the square root of 4? The square root of 4 is 2. But in Algebra 1, we focus on not just the fact that the square root of 4 is 2, but we also focus on the fact that the square root of 4 is actually plus minus 2, positive or negative 2. Now, what does that mean? It means that simply, I asked what number times itself gives you 4. That's what the square root of 4 is asking. It's either 2 times 2, but it could also be negative 2 times negative 2. They're both the same number. They're both times each other the same amount of time, twice, and they both render you with the answer of positive 4. So what we find out is a little bit of a, I don't mean to say this was a mystery or even go so far as saying it was a lie, but we find that up until now, whenever we've done square roots, we focused only on the positive root. A lot of you out there are a little bit shocked right now to find out that the square root of 4 actually has 2 answers, not just positive 2, which you've always grown to understand, but also negative 2. So, surprise, there's 2 answers to all radical, or at least all square root or even root answers. So let's just go with that, right? Let's just go with that for a moment and test this out. So what am I saying? I am saying that the square root of 16 is not just 4, but yes, it's plus minus 4. I'm saying that the square root of 81 is not just 9. It's plus minus 9. I am saying that the square root of 144 is not just 12, but it's plus minus 12. And so we have this little cute symbol. I love this symbol. Do you know why I love this symbol? Because if I didn't have this symbol, then when I was asked for the square root of 49, I would have to go so far as to say 7 and negative 7. I would have to actually write both solutions independently, and that is more work than I would like. So I just write plus minus 7. It's like the greatest thing ever, isn't it? All right, so with that in mind, whenever we give our solution, whenever we find a square root, a fourth root, a sixth root, we're going to go ahead and just write the plus minus, indicating that whenever we have an even number of numbers timesing to each other, it could be a positive number that timeses that gives us a positive, or it could be a negative number that timeses to itself, and that gives us a positive, sorry. Ooh, okay. So what else? What else could there possibly be? Well, there's a little bit. I just went over a couple one. Let me give you a couple others. Do these real quick for me. Square root of 25, square root of 1, and square root, I'm trying to think of ones I didn't do yet. There it is. Okay, so you already know those answers, right? Go ahead and throw them down. You did not just say 5. Did you really just say 5? What did I just tell you? Good job. Plus minus 5. What about the next one? Plus minus 1. 1 times 1 is 1. What's the last one? Plus minus 8. Excellent job. Now, you're ready to move on to phase 2, because we don't always give you these perfect little roots, these perfect little radicals. They're awesome, but that doesn't always happen. Square root of 40. Now, square root of 40, I think the number one most common answer to give me is the square root of 40 is 20. Okay, 20 plus 20 is 40. Remember, we're multiplying. I'm asking you what two numbers that would times together would give you 40. And I would also, hang on, here's the fun part, be able to find a perfect square factor. Okay, hang on. Let me just rewind for a second. Perfect square factors. If you could list all of the perfect squares from 144, and I'm starting at the top of the 12s times tables, right? If you know your times tables, you were in elementary school, you memorized probably your 1s through your 12s. So if we start at the 12s and work our way down, what's the next perfect square? This one belongs to the 12s times tables. What's next? Yeah. So it's 121. And then what? So we said 12 squared, right? 12 squared. Oh my gosh, that didn't come out. Sorry. 12 squared. This is 11 squared. What's 10 squared? 100. 9 squared. 81. You see where I'm going with it? Okay. If you could list every perfect square from the top down all the way to 1 squared, you would have all your perfect square factors from 12 squared to 1 squared. These are the numbers that you want to be thinking of when you're doing this next activity. So, if we go back to the square root of 40, and you think from the top down, from 144 all the way down to 1, which of those factors is actually a factor of 40? And more importantly, what's the highest, the largest, the greatest perfect square factor that you can come up with? Now, the bottom of the list is 1, right? And 1 is common to every single, excuse me for shifting, pardon, okay. 1 is a common factor to all numbers. So that's not ever going to happen to help us. It's always going to happen. It's just not going to happen to help us. So really the number that I start with is the square root, or the square of 2, which is 4. So of all the factors from 144 being 12 squared all the way down to 4, which is 2 squared, which is a common factor of 40? Well, this one's a no-brainer, 4. Because there's really nothing, hang on, did I say there's really nothing else? Well, think about it for a minute. If it was 4, this would be 10, right? Because 4 times 10 is 40. And if I was to break down 10, it would be a 2 and a 5. Now, the 2 and the 5 are prime factors. I can't break them down anymore. And do you notice that they're different numbers? It's not like I came down here and I broke down a 2 and a 2. I broke down a 2 and a 5, which means I can't do anything else to 10. And so I know I've broken this down perfectly. So let's take a look at what I've been able to achieve. The rules of square roots, or the rules of radicals, is that the square root of the radical is equal to the product of its factors. So I could say the square root of 40 is equal to the square root of 4 and the square root of 10. And I just did right there. So the square root of 40 is equal to the square root of 4 and the square root of 10. And what is the square root of 4? It's 2. The square root of 4 is 2. You're saying, believe it's a plus minus 2. Yes, it is. It's plus minus 2. And then the square root of 10, well, I know I can't simplify the square root of 10 anymore. And so it's 10. Now, just as a side note, a lot of times what we do is we just go with the positive root. If I'm not doing anything fancy, I will just write the positive root, meaning on a lot of answer keys for the solution of the square root of 40, you'll see 2 root 10 without the plus minus. And so it's totally okay to just write 2 root 10. But you do have to understand when you're working, when you're actually using square roots, you're trying to find solutions to equations, you're going to need that plus minus option in there. Let's just jump right into another one. I know your head is spinning. Relax. 120. I'm going to break this down really simple. Remember the list. It starts at 144, goes all the way down to 4, right? Can you name a perfect square factor for 120? And can you possibly come up with the largest one, like the one at the highest part of the list rather than down at the lower part of the list? Well, let's just go through our list. 144, no, no, 2, and well, sometimes you just got to break it down with what you got. I know 4 goes into it, and I know 4 is on my list, but I want to see, is there a bigger one? Well, 4 goes into 120 how many times? It's 30, good. Okay. The question then becomes, can I break down 30? Does 30 have a perfect square factor in it? Well, if you don't know, you just break it down, right? 5 and 6, and 2 and 3. And if I did that correctly, if I times everybody back together, I wind up back with 120. So we want to double check. 4 times 5 is 20, and 20 times 6 is 120. So then, here I go, 4 times 5 times 2 times 3 are the factors of 120. Now, why did I break them down like that? Well, first of all, I locked in my square root of 4, right? Oh, that's a nice purple color. The square root of 4 is good. I was searching for perfect square factors. But then when I came to the square root of 30, I was looking to see, does 30 have a perfect square factor? And I come down here and I find out, no, it doesn't. Those are all primes. The square root of 30 could be broken into square root of 5, 2, and 3, but there are no common factors 5, 2, and 3. It's not a 5 and a 5 and a 3, or a 2 and a 2 and a 5. And so what I find out is the square root of 30 is simplified, but the square root of 4 isn't. It's 2. And so my final answer for the simplified version of the square root of 120 is 2 root 30. Easy peasy. Let's try another one. Now, I've been giving you ones that all have the perfect square factor of 2. So hang on a second. Let me see if I can come up with doing a little research. Come on, I got to come up with a prettier one than that. Ahoo! Of course. Let me try. I got it. I don't like this color though. Let me do one that's easier to see. The square root of, drum roll please, let's do 150. All right, square root of 150. If you can't think off the top of the highest perfect square factor, then just break it down into 2 numbers that you know go into 150, that are factors of 150. And if you can make one of them a perfect square, it's awesome. But what if you can't think of it? I mean, what if all you think of is 15 and 10? And you think to yourself, well, okay, well, square root of 15 is not a perfect square, and square root of 10 isn't a perfect square. I haven't found a perfect square factor. So either the square root of 150 is already simplified, which it's not, or I just need to search for the factor that I'm not seeing. Now, just so you know, I know what that perfect square factor is, but I want to show you how to find it if you don't. So if we come down to the square root of 15, what about the square root of 3 and the square root of 5? That would be 15, right? And then we come here and we say, what about the square root of 2 and the square root of 5? That would have been 10. Aha! Now, do you see any repeats? What about the square root of 5 and the square root of 5? The square root of 5 times the square root of 5 is the square root of, exactly, the square root of 25. And so what I realize is I could have broken it up like this. The square root of 25 times the square root of 6. So 6 times 25 is also 150. And the square root of 25 is a perfect square, which is why it makes it more appealing to me to have been a factor I had picked up off of the top of my head. But a lot of people, they just don't see it. And so you have to go about it in a different way so that you can come to the same answer in the end. Square root of 25 is 5. Square root of 6 is simplified because we know its factors are just 2 and 3. Prime factors, nothing else we can do there. And so it's 5 root, oh, that was the eraser tool, sorry, 5 root 6. Final answer. All right, moving on, onward and upward. Let's do 132. The square root of 132. Now try pausing this and do it yourself. See if you can at least break it down into the perfect square factors. That would be awesome. And I will just start here. If you're not going to pause, just going to give you a chance. It's now or never. Okay, guys, sorry, I had to pause because I don't have a calculator, so I just wanted to double check. All right, so the perfect square factors are, I did my little math and I got a 4, and I forgot what I said. 4 times, what was it? 4 times 33? 4 times 30, whoops, sorry. 4 times 33. And I'm just double checking. 4 times 33. Yep. So 4 times 33 is 132. And I went with that because the square root of 4 is a perfect square factor. And 33 is just 3 and 11. So if you multiply 3 times 11, both prime factors, so I'm not going to get any more out of that. Square root of 4 is 2. So 2 root 33. Let's try another one. I'm going to give you, here a minute this time, I'm going to give you a couple of them so that you can think about these. Hold on 1 second. Okay, so this time I got 2 for you. Square root of 72 and the square root of 300. Go ahead and pause me. Do those, see what you think about those, and then come on back. All right, for you guys, I'm going to jump right into it. 72, I hope you recognize it. It's 9's timetable, so 9 times 8 is 72. So you think easy breezy, I've got it. The square root of 9 and the square root of 8. Now I know that the square root of 9 is flat out 3. But then I always, don't just jump and say that the answer is 3 root 8, because the square root of 8, I happen to know, can be broken down into the square root of 4 and the square root of 2. And what else do we know about the square root of 4? The square root of 4 is 2. Now the square root of 2 is prime, so I'm good on that one. But what do I do with these two numbers? I actually took 2 separate roots out and got 3 and 2. Well, you got times them back together. 3 times 2 is 6. And that means that the final answer is 6 root, who got left in the root? 2. Final answer, 6 root 2. Now what does that mean? In the grand scheme of things, it means you didn't notice that 36 goes into 72. It goes in twice, right? Because 2 times 36 is 72. That means that when you broke down 72, the biggest perfect square factor you could have picked was a 36 and a 2, meaning we would have gone faster just finding the square root of 36 is 6 and having the root 2. Same answer. We got there, maybe we got there a little faster one way versus the other, but we still get the answer. So now we're at the square root of 300. Again, think of the biggest possible number you can that's on that perfect square list, and hopefully you see it, because it would be really fast if you did. It's the square root of 100. The square root of 100 times the square root of 3. I love this one because 3 is a prime number, and so its factors are 3 and 1. There's no hidden perfect root in there. And the square root of 100 is 10. So my final answer on that is 10 root 3. All right, guys, I'm trying to keep these videos a little shorter than usual, not my normal 45-minute, discovery and experience. So this is a brief little how to simplify radicals. I hope it helped. If it didn't, let me know, and I'll just try another one. Until then, guys, see you on the flip side.